Okay, thanks a lot, and welcome everybody. Yeah, my talk's called Test-Driven Development with Django 1.4, and I have this subtitle, really just do it, because testing is hard, and when you think about it beforehand, it always feels like a pain in the ass, and you don't really want to do it. You just want to do prototyping, you want to jump right into your project, and you don't want to care about tests. But I have created around 20 websites during the last 2 years, and I try to do all of them in a test-driven manner. It's not always very successful, but most of the time I try to stick to it, and yeah, some patterns emerge that I would like to share with you guys today. So why should we do it? There are actually lots of reasons. One thing that I pretty much like about test-driven development is that you have to think about your own APIs before you actually implement them. It's like when you write the test and there's no code at all, it's like you have to import that imaginary code and you have to call the imaginary function that doesn't exist yet. And this already makes sure that you will make the API beautiful, that you won't have parameter overloads in your method and stuff like that. And yeah, so it will make sure that you will write beautiful code. It helps with refactoring, obviously. I mean, refactoring with Python is always something that I find is a bit difficult because of the dynamically typed. Because it's dynamically typed. So when you have 100% test coverage and you change your method name, you can be quite sure that the test will tell you where else you have forgotten to change that method name as well. So you don't really need a fully blown IDE with refactoring tools, and I don't really trust these tools with dynamically typed languages. So I rather trust my tests when I do refactoring. And I can guarantee you, I've done refactoring for like 20,000 lines of code projects recently, and it was really major refactoring where we changed some really low-level API that almost all parts of the project depended on. And okay, it took me maybe 8 hours or so to dig through the whole code base and get the tests up and running again. But once the test ran and all tests ran through again, it just worked. So refactoring is really testing is really good for refactoring in Python. It gives you confidence in your code base as a result. And another interesting point is when new team members join, you can just throw them into the cold water. Tell them, okay, I want this feature, try to implement it. I mean, with web development, it's quite simple. You can just point him to the website and he can figure it out. He can try to find where's the URLs pie. So, okay, which view is serving this code? Aha, there's the code of the view. Okay, now I can implement the feature. But maybe he will break something else, right? And the test will make sure, if he runs the test, he will see that maybe he has broken somewhere else in a completely different file. So, but it's no problem, because the test will tell him, and he will know, okay, maybe I'm not done for today, I still have to fix something, or I have to rethink my code. But actually, this person can be productive from day one. Yeah, as a result, test is like extra documentation. I like to have, when I do the assertions, like when you do tests with Django, you know you have this self.assert true, self.assert equal, and stuff like that. I like to append custom messages, so the message will be quite verbose and tell in a rather verbose way what I'm expecting, what should happen here, right? So when I won't just type self except true results equals 5. Somebody who reads that test will not know, okay, what is result and why should it be 5? So I will append a message like, when somebody opens this website on a full moon day, there should be a big 5. So that everybody knows, this is why it should be 5. Okay. Testing will actually save you time. And when you start doing it, you will think it's a big waste of time, because usually I write maybe 5 times more code, more lines of code for tests than for the actual implementation. Sometimes even up to 10 lines, 10 times more code. But once you have to touch that code again, and once you have to add a feature, or you add a new parameter to that method and give it more functionality, you will be super happy that you have written those tests before, and you will be much faster. You can just think about that new feature, implement that, and don't think so much about what am I going to break, and stare at the code and try to think about all consequences, because you have thought about that one before when you have written those tests, right? So In the end, although it's a pain in the ass at first, in the end it turns out it's a highly rewarding work experience. I really love to start my workday, plan my tasks for today, write the tests, and then I know when I can call it a day, right? I can call it a day when the test is green, when it says 0 failures. Then I know, okay, I've done everything I wanted to do today, I can go home. Okay, of course, it can turn out that I planned something that is too difficult and the test just the test just never runs through and it takes hours and hours to fix them. But again, I mean, then it was just a hard software problem to solve, and in the end, when you finally fix it, it's still a rewarding experience and it's definitely fun to do it. You should definitely do test-driven development. I don't know if you have to stress that much these days. When I graduated in 2005, test-driven development wasn't mentioned once in 3 years in university. Nobody talked about this at all. I had to teach this myself, reading blog posts and reading books and stuff like that. Yeah. So I wonder if this is still the case, but I feel like, I mean, agile development and all this stuff is all the rage these days. So hopefully this has arrived in universities and schools already. I think there's no alternative to not doing test-driven development. It's just no alternative. Don't do it. Okay, just quickly, I like to keep it simple. I just will differentiate between two kinds of tests. We will have unit tests. They should be small. They will test very small, precise parts of your code. Like, for example, if you have a model class, and that class has for example, a get full name method that should return the first name and the last name concatenated. This is a method that I will test. So I will write one test for this method. Or maybe if that method is more complicated, I will create one test class that has several test methods that test different aspects of that method I'm going to test. In any case, each unit test should be extremely fast. Yeah. So this is why I separate integration tests. This is a problem with Django. It makes it extremely easy to do integration tests. We have the self.client.get or self.client.post, and it's extremely slow. It will go through the whole life cycle of a web page. It will go through all middlewares and context processors and whatnot. It will start the database. It has to load the whole settings file of Django and everything. So, I mean, when you write 2 of them, maybe they run in 0.5 seconds. But when you write 200 of them, you will feel the pain, and they are actually very, very slow. And I mean, this is important. Your tests have to be able to be run in, I don't know, less than 10 seconds. If they become slower than 10 seconds, you will execute them less often. And when you don't execute them all the time, you will start like, I don't care about the test anymore, because when I'm writing this test now, I have to wait another 20 seconds to see if it fails. And I mean, the point is to do this test-driven development dance, which I will show later. Test, implement, fail, implement. You know, so they must be fast. But the problem is integration tests is still important, because maybe we have, especially in Django, maybe we have these template tags, custom-made template tags or template filters, which also run a lot of code. And maybe there's something in your template that fails. Maybe you are calling the URL template filter, but the name of the URL that you inserted just doesn't exist. This is something that you can't really test with a unit test. So integration tests are just good for just loading the template and seeing if it's possible to get a 200 response status code and see if that template can be loaded. But by separating them into separate folders, I can make sure that I have one command that just runs my unit test, which should run less than 10 seconds. And I have another command that just runs everything for making sure that my coverage file is created properly, my coverage report. And of course, before I push to production, I will run all tests, obviously. And in that case, it's okay if they run a minute or 2 or 5 minutes. I mean, for extremely big projects, maybe they might run 5 minutes. Just quickly, it's just some links for the uninitiated. If you are new to testing, these are some links that you should have on the radar and read about it. Unit test is the Python module package that deals with all kinds of testing. Nose, I like to use Nose because it makes finding the files that you want to execute for your test a bit easier than unit test. I think unit test, you can only give it a pattern. Like, for example, execute any file that has _test.py in its name. But with Nose, you can also you can add a pattern, and you can add an exclude, like execute anything with this pattern, but exclude everything that has this pattern. And I think I wasn't able to do this with unit test or unit test 2 yet. If it's possible, I would drop those, but as long as that's not possible, I still advise to use those. Coverage is something I will show. I won't talk about much about that one. Mock, yeah. Sometimes when you have, for example, you have a view that depends on something else that is very hard to test. For example, you want to pull some JSON data from another API. Maybe you want to, I don't know, get some data from GitHub or so. I mean, it's hard to test when maybe GitHub is just down, and then you can't run your tests anymore. So you might want to mock out this functionality. Like when your website calls your API wrapper around GitHub, you can just mock that function, like get GitHub data or whatever, and make sure that it just always returns the same JSON string, because you know GitHub will always give me this JSON string, so I will just assume I will get it all the time, and I don't really want to. And I mean, if you don't mock this out, you have to wait for the request to return, right? And suddenly the unit test becomes more of an integration test again, because it will take a lot of time, and we want to keep it fast. Fabric doesn't really have to do anything with testing, but it's a great tool for automating stuff. And yeah, testing only makes sense when you automate it and when you run it all the time. And so I will show you a little bit about Fabric later, maybe if there's enough time. And Watchdog is something that is very useful for running your tests all the time when you save. And I mean, if they run in a second, why don't just run them all the time? Whenever you save a file, just run your test. I always have another terminal window open that just runs the test all the time. And whenever I'm hacking around and I save, I can always see in the other terminal window if it's turning red or green. Okay, that was the Python testing toolbar. That was generic to any project. When you go to Django, there are lots of tools that you can use to make testing easier. First of all, you should just read the topic on testing in the Django docs. It's a very extensive topic about what kinds of facilities Django provides for testing purposes. But you should be careful. You should beware. They tell you a lot about Selenium and self.client.get and stuff, but they don't really mention that this is slow, right? And that you will get into trouble when you just use this. Yeah, I mean, it's there. They describe, oh, you can do this, and it's so cool. So you start doing this, and you end up with a huge test suite. You have 200 tests, and they run in 10 minutes, and you never run them again because you are so impatient, right? So don't use self-client.get in your unit test, and also don't use JSON fixtures. Django has this feature for test classes to provide JSON fixtures. So whenever this test gets run, it will look for the .json file and load these fixtures into the test database. It's pretty slow. It's also very difficult to maintain. Like when you change that model significantly, you have to change that fixture file as well. And I mean, it's not fun. It's easier to use Factory Boy for this. Factory Boy, as the name says, is a system to create factories for generating your Django models and your Django objects. Yeah, Django Nose is a custom test runner that, as I said, helps discovering the test files. So you can separate the integration test in a different folder and the other tests in your normal test folder. Django coverage, I will show that. It shows you the coverage report with nice HTML markup. And Django Jasmine is good for testing JavaScript. Yeah, you will probably want to have a certain structure for your tests. I would always advise to create a custom test runner, because usually when you run manage py test, it will just run all tests. It will run all Django tests. It will run all tests that are in your installed apps. And usually, I mean, when I use a third-party app, I make sure that this app has good test coverage already. So I just assume that it's tested already, and I don't need to run these tests as well. And it never happened that a third-party app has a good test suite and they are all running through. But when I use it in my own project, it's suddenly failing. It never happened before to me. So I just don't test third-party apps. I only test my own apps. Yeah, as I said, separate integration test from unit test. Create factories for all your models instead of using fixtures. Provide a requirements dev text file. Usually, all these tools that I have mentioned just now, they are not needed for deploying your stuff on the server. And maybe you just don't want to have them in the requirements text file when you deploy your website on the server. Maybe it's just bloat on the server. You don't want to have it there. You're never going to SSH into the server and running your test suite. At least I don't do that. But still, if somebody else joins the team, it must be incredibly easy for him to start testing, right? If I don't know, if he starts the test command and he gets lots of errors that like some packages are missing, he will give up and he will be frustrated. So give a requirements dev text file so that in the README of the project, it just says run pip install requirements dev and then run fab test. Bam, you have, and then see that the tests are running through and then start working. Okay, so this could be a possible project layout. So when we run Django admin PyStart project, we will get a few files, but we will add a few files, right? We will add the requirements dev file, we will add a fab file, and with Django 1.4, the project layout has been changed, right? Usually the manage py file, no, actually, it creates this my project folder, which hasn't been there before, I think. Usually,
it used to be inside my
yeah, right. So, and in the my project folder, I usually create the test runner because this is something that's global. It's not tied to any app, so we can have it in the my project folder. And yeah, and here factories. Usually, the my project doesn't do anything. It's just like a container for the settings, and I would do anything that there's actually implementation. I would do it in apps, but still stuff like the authentication app, for example. Yeah, we have this user and groups models. It's you still when you're writing tests and the test depends on the user, you might want to create a user object. So I would put the factories for creating user and group objects here into the my project because this is something that's global. All my apps might want to use this, so I can import it from here, right? And yeah, so and when you run Django admin PyStart app, you will get inside this root folder, you will get the app the folder with the name of your app. And here's the same. You have, this is the actual implementation of your app. You have a test folder. You have factories for your models. And obviously, for each file that implements something, there should be a corresponding file that is named _test to test that stuff that is in there. But we will separate integration tests into its own folder. So the views test, which usually always use self-client.get, I will put them into the integration tests folder so they are separated. And I can easily run my tests without running the integration tests. Yeah, and the requirements text file could look like this. We will use Django extensions, Fabric, Factory Boy, Django Nose coverage, Django coverage, mock, Watchdog, Selenium. A test runner is pretty easy. I'm using the Node test runner, Nose test runner, sorry, and also the coverage runner. There's a nice runner that helps generating the coverage report whenever you run your tests. And I don't feel that it has a lot of impact on the performance of the test, so I just generate the coverage report every time I run the test. Doesn't really matter. And luckily, when you derive from both of these custom test runners, it still works. But only when you do it in this order. If you derive from Nose test suite runner first and then coverage runner, it will not work. Okay. We need to do some magic in the settings file. We need to separate the, usually the installed apps setting, as you know, is just a long list of apps that you want to use. I like to separate this so that I have external apps and my own internal apps. These are the ones that I'm going to test. And when you concatenate those two lists, you will get the installed apps setting again, which is required by Django, right? Now here's the magic. When you're running your test, you will give the Django manage py test command the -- settings flag, and you will give it the test settings as its settings to use for running the test. And first of all, we will just import all the settings that we have anyways, and then we will add another app, Django Nose. So we don't want to have this app in our installed apps when we are running the site on the production server, right? We only add it when we are running our tests. So it removes some bloat from the real execution. You can set the database to SQLite in memory. It's the fastest way to run tests. And this one is pretty cool. I discovered that a few weeks ago, and it makes an incredibly huge difference. When you set the password hashers to MD5, because in Django 1.4, they have updated the password hashing to something else because MD5 is obviously not secure enough anymore. But the new thing is actually pretty slow. And whenever you have a test that does self.client.get or does anything with self.client.login that somehow has to do with the user, or when you just create a user object, and I mean, if you have an application, let's for example say you have an application with blog posts, and the blog post belongs to a user, right? So almost every model that you use will somehow be connected to a user. And when you create test fixtures for this from this model, you will also have to create users all the time, and each user needs a password, right? So you would be calling the password functionality all the time. So by changing this to MD5, I had a test suite that ran like maybe 3 minutes. I changed it to MD5 and it ran in 20 seconds. So it makes a big difference. Yeah, here, email backend, you can change it to local memory as well. You can instruct South not to run its migrations when you are testing, because this might sometimes break stuff when you're using custom test runners. Yeah, here we will set to use the test runner that combines nodes and coverage. And here are some settings for coverage, like which is the folder where the coverage output should be put, and here are some folders that coverage should ignore, because otherwise coverage would try to would always tell us that, oh, there's not 100% coverage because we didn't touch the URLs PyCode, and it's pretty hard to get coverage in these files. Okay, factories. If you haven't used Factory Boy yet, it's that simple. You just import the model that you want to build a factory for. Then you inherit from factory.factory. You say it's a factory for the model that we have imported. And then you can just say, for example, if the model has any fields that are mandatory, you must put them in here and you must give them a value. So whenever I will call entry factory, it will create an entry model, an entry object where message is set to this. And apparently, in my example, the entry model has a foreign key to user. So I will say this is actually a sub-factory to the user factory. And I told you that for these global factories that might be useful to any apps, I put those into my project. So there's a factories file as well, which implements a user factory. So whenever I call entry factory, it's just this instantiate entry factory, and you will get back an entry model, an entry object, sorry, and it will automatically go down into this factory and do the same magic down there as well. Okay, so yeah, this is how an integration test could look like, but you probably know this, just calling, oh yeah, because this is the details view, right? I want to test if I can call my details view, and I can only call a details view if there's an object with a primary key, because the URL will be something like entries/5, right? So first of all, I have to create an entry, and by using the factory, it's just like this. Just instantiate the factory, you will get the entry. Then we can call self-client get with the primary key of the object, and we can assert that the status code is 200, for example. And finally, we have at least a test that just loads the template and makes sure that everything works. Yeah, so this is the test-driven development dance. I wanted to show this in a terminal, but we won't have enough time for that. So it's usually when I create a new app, the first thing that I will do, I will write the self-client.get status code 200 test. And when I run the test, it will say no reverse match, reverse for home with arguments blah 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 not found. Obviously that's correct, because I haven't added this view to any URLs file, urls.py file yet, right? So I will go into the urls.py file and call home view as view. So I'm using class-based views, and it will say name error. Home view is not defined. Okay, so I will do from my app.views import home view. Then it will say import error, cannot import home view. Yeah, obviously, because I haven't implemented home view yet. So I will go into the views file and implement the home view file. And then it will say template does not exist. And this is pretty useful, because if you are using class-based views, they if you don't provide the template name attribute on this class, it will try to make up the template name from the model name, right? And I can never remember, for example, for an update view, okay, what was it? Was it entry_update, or was it entry_form or something? And I would have to go into the code or into the docs and find out how Django class-based views generate the template names. With this test-driven development approach, I just look at the error, and it will actually tell me what name it expects. And I will know, okay, now I have to go into the templates folder and have to create a template file. And then finally, I will get a 200 status code, and I'm good to go actually into the template and implement some HTML and yeah, and create my web app. Okay, this is about Django projects, maybe you want to create reusable apps. Actually, you should do, because I mean, it's just so cool when you start a new project for a new customer to do pip install this and this and this and this and that, and it's all my own stuff on GitHub, and suddenly you have lots and lots of features that are beautifully tested, and it's all your own code, and you don't have to copy and paste code from other projects into your current project. So, in order to be able to host your reusable app on python.org on the Python package index, you would have to have some boilerplate stuff here. Especially this setup py is important. I won't go into how to package Python projects in this talk. It's too complicated. But when you check out this from my GitHub repository, maybe it works. I didn't test it, but it should probably work. You can run this command for uploading this repository to PyPy, and then other people will be able to install it with easy install or pip install, right? So the actual app will be in its own folder. This is just normal, like we would develop an app inside our project. It's the same stuff. This is the actual implementation of our app. And again, we will have a tests folder with factories and integration tests. So it's the development of the app as a reusable app is pretty much the same. But the problem is, how do we run the tests? Because there's no manage py. We cannot run manage py test, right? We don't have a Django project. We don't have, I don't know, we don't have settings, no database, no nothing, no URLs py, no templates, right? So there's a little trick that I like to use. You will see that there is a URLs py here inside the test folder. So maybe we should call this test URLs py to not confuse people. This file will be used from a script that I always call run tests py. And Django has this cool feature: when you import from settings, you can test if the settings have been configured already. If not, you can call settings configure, and then it's like these then it's like you are working with an actual Django project, and you can have all the settings here that you would usually have in your settings.py file. And here we will set the root URL comp setting, which is mandatory, to the URLs py in your test, right? So we could even have make this more modular and call this in different ways. Sometimes we use a URLs py where our tests are hooked with a namespace, and sometimes we just call it normally, for example. Yeah, so you will have to add all settings here that are necessary to run your project. So for example, if your app depends on any other app, you would have to add it to installed apps and stuff like that. Oh yeah, this is, the file is so long, I split it up into 2 slides. And so after all this setting stuff, you will have this no coverage test runner again, if you like to. And then here's the magic: you will call the run tests method on your custom test runner and give that back to the terminal. So theoretically, if my prepared project here is still fine, and the good thing about this is a project that will be on the Python package index and probably on GitHub, and people might want to collaborate. And now you can tell them, just clone it and just go into the test folder and call run tests. And there he is. He can run your tests immediately, right? This is what I said. It must be that simple to run the test, otherwise people will screw your project up by just implementing features but not running the tests. Okay. Here's another cool thing about when we are just talking about people screwing up your project. There is this tool called travisci.org. Pretty awesome stuff. You can log in with your GitHub profile, and then all your GitHub repositories will be listed here. And you can flip a switch, so to speak, so that for this repository you want to create a service hook for Travis, okay? And then whenever you push to this repository, Travis CI will notice about this and will try to run your test. In order for this, to make this possible, you need to add a .travis.yaml file at the root of your project, and the file is pretty simple. We just say, okay, this is a Python project, and we want to test against these Python versions. This is my requirements text file for setting up my environment, and this is the command for running the tests, right? And we can just run these cool run tests py for running the tests. So when it works in our terminal, it will also work on the server of Travis CI. So let's try to break the tests. How can we do that? Let's say. Let's say. Let's say we change this to 300. Yeah. Okay, it has been pushed. And now it's yellow because they are executing the tests, and it's all done with socket.io. I think it's totally live. So we can see that he's currently executing the requirements text file and installing the whole environment. And in the end, I will get an email saying that tells me that my open source project is currently failing because somebody pushed bad code, and it will tell me who it was. It will give me the commit, a link to the commit right to GitHub. I can see the diff. It gives me the commit message, so I can already guess what it was about. It's pretty awesome. It's really awesome. And yeah, we should. Okay, now it's compiling something. Okay, you get the idea. Oh yeah, this is pretty difficult. I just figured it out just now, and I think I'm running out of time. Okay, should we do a question and answer session, or should I go on for another 5 minutes with my talk, and we have lesser time for question and answers? Who wants to hear more? Okay, then we will go on. I will not talk about this JavaScript thing now because it doesn't really work. But let's talk about Watchdog just quickly. When you do pip install Watchdog, you can execute your tests every time when you save the file. So when you do pip install Watchdog, you will have a command line tool called watch me do at hand, and it takes a couple of parameters. So you can say watch everything below this directory recursively, go into all subdirectories, ignore file system events on directories because we are not saving directories, we are just saving files, and only care about .py files. And wait, if there are wait means like if there are several file system commands at the same time, it will not execute the tests asynchronously 10 times, and then you have to wait forever for all of the tests to run through. It will just run the first one and then stop. And this is the command that should be executed if anything fails. Oh yeah, this leads us to Fabric, which is something that I also wanted to show. By using Fabric, you can make life easier for contributors to your project. So I usually define this test method. So I'm calling manage PyTest with my project's settings file. And if people call it just so, all tests will be run. Yeah. And if people call it integration equals 0, it will exclude the integration tests. So and Fabric works like this. When you just do pip install Fabric, and then you put a fab file. Where is it? You put a fab file.py file in your project folder here, and when you are in the same folder as the fab file, you can run fab test, for example. So it's pretty much like make files. Yeah. So yeah, makes life easy for developers. Just tell them run fab test. It's something that everybody can remember. You can make sure that they definitely will run all your tests all the time. Okay, there's one interesting thing. What about fixtures now? We still have this dump data and load data command that Django provides, and I'm telling you, don't use fixtures. They are slow, they are messy, they are hard to maintain, but they can still have an interesting purpose, and that is bootstrapping your project, right? What if a new developer joins the project? You tell him, yeah, clone the repository from here, run the test like this, but then he wants to implement a new feature, and you tell him, like, I don't know, oh yeah, when there's a blog post that has more than 250 characters, the word wrap is a bit weird. Can you fix that? And then first he has to like start manage by run server, and he has to create this blog post so that he can see the problem, right? So maybe you want to just to provide some fixtures so that whoever clones this project can run this fab rebuild command down here. And what it does is it will call resetDB. This is a command that we will get when we use Django extensions. It will just delete the whole database and recreate it. Then we will call syncDB and migrate again. And after that, we will run the load data command here, which is just a bunch of manage.py load data commands, because usually you should separate all your JSON files because you will not be able to, for example, if another app depends on the user model, and you didn't load the user model yet, you cannot load the fixtures of that app because the foreign keys, you will have foreign key constraint problems, right? Yeah, so let me just demonstrate this. Let's assume somebody has just downloaded this project and there's no database at all. So what will he do? He will do fab rebuild, and it will create the new database, and it will install all the fixtures. So theoretically, when I run manage.py run server now, this person should be able to see my app, and there should be entries inside, and this is the case, right? And I usually, I put an admin user with password test 123 inside the auth fixtures, and yeah, so people can just start run server, they can go into the admin, and they can start using the website. And I really do this hardcore, like when I have a blog, or for example, I'm using Django CMS. Django CMS has lots and lots and lots of tables, yeah, and it's pretty painful to create fixtures for that, but I'm doing even that. So let's say we have a customer project with a small website about a small company or what, and they have about, and they have news, and they have the home page. I make sure that there are fixtures inside for creating all these pages. Maybe there are some plugins on each page, so I will make sure that the plugins are there. And so anybody who starts working on this project can run fab rebuild, and then he can go to the website, and it just looks like it should look like, right? Okay, I guess that's all I can tell you in the short time that we have. Thank you very much.
This is on your GitHub?
This is on my GitHub. Yeah. And I will also upload the slides somewhere, but I didn't have time to do that yet. Questions? Yeah? Oh, sorry.
How do you test a feature that has something to do with REST API when you need to dispose of the spoilers after you run the test?
Yeah.
Do you need to make a real call to the REST API, or you fake them?
Do you mean a REST API that belongs to my own project? Pardon?
The third party.
Third party, yeah. I would use mock. Yeah, usually you will have in your code, you will have a call where maybe you use URL-lib or something to call that API, right? And you can mock the URL-lib, what is it, .get or so? I can't remember that function. You will mock it out, and you will make sure that the return value is always the same JSON string that you want to have for your test. There was one more question? Yeah?
So I was using unit test too.
Yeah.
Unit test.
Uh-huh.
And by building test suites for each one, but using the built-in unit test suite,
Yeah.
which allows you to, while you have to manually specify what you want to have, you can specify patterns in your module load.
Okay.
And for using that, you can still do the separating out your unit test and your integration tests by dropping them into different test suites and putting a top-level test suite in your project.
Okay.
As well.
Yeah. Okay. Sounds cool. Maybe you can show me how you do that. Then I can drop nose. I got scolded by some other developers for using nose when unit test is also pretty good. Oh,
nose actually I found was easier to set up. In some
yeah,
ways,
yeah. It's pretty straightforward.
It's
Yeah,
another
yeah.
requirement. And they do the coverage a lot easier.
So I forgot about one thing, that is coverage. So I because of that test runner that I implemented, it creates a coverage report on each test. So I can drill down here and go into each module, and I can see all lines of code. And whenever I implement something and I don't write a test for it, it will be red in here, right? And on the main page, the percentage will be below 100%. So I will know which parts of my app are not covered by tests yet, and where I have to do some more work.
Is this generated by coverage.py?
Yes. And in conjunction with Django coverage, I think Django coverage has some nicer styles also, but yeah, it's...
Yeah, then we use the output, just use the console output.
Yeah, you can use the console output, for example, when you want to make sure that people cannot push before coverage is above 90% or so. Then you would probably want to use the console output because it's easier to make, to parse it and search for the 90% or, yeah.
Yeah, this one look useful too.
Yeah.
Because you can drill down to
Definitely. I mean, for example, let's say I'm going into my app, into the views and into the models pie, and I'm going to add a method here. Okay. Now when I run my test, the coverage report. Oh, what the hell? Ah. Ha! So good that we run the test. The test will still run because I have added something that is not covered. But now when I open coverage, which I will always do before I deploy, I will say, oh, 80%, what's going wrong here? And then I will say, all right, I still have to write a test that will call this foobar method, right? It's extremely useful. A cron job?
Yeah.
For what?
Like in environment. You know, like in Jenkins you can do cron job. I'm wondering if this type of cron job.
For running the tests or?
Yeah, like in pulling the library, update the library.
I don't understand. I'm not sure if I understand correctly. I mean, running the test, you don't need a cron job for that because you run them all the time anyways. And every time you run them, this file will be updated.
Sometimes you want to update the environments like daily or something.
Yeah. If I want to update my environment, I would update the requirements text file and increase the version number or something. And then I would just call pip install. I mean, it happens quite rarely that I ever update any package. I mean, and my deployment scripts are made in a way that when I call my deployment script, it will, on the server, it will do a git pull. The git repository is on the server as well. And then it will do a pip install -r requirements text file. It will just run through this requirements text file on every single deployment. Usually it will just say requirement is being met, and it will do nothing. But if the version number has been changed, it will download and install that new package immediately. And after that, it will copy all the files to the www folder, whatever, and make it and publish it. Okay.
One question I have is about unit test versus integration test, and let's say the complex level of your projects and so on. Do you have any, let's say, recommended structure if you slowly get into a more complex structure? Because, well, in the job which I have at the moment, we have even the most basic installment of our application, of our framework, has around, I think, 200 tables at the moment. And so we focus a lot on integration tests, because often we can't be sure whether it won't break at any part if we change
Yeah.
So of course we can have a localized unit test, but how do you deal with such a problem, or didn't you run into such a problem with Django projects so far?
I mean, I always start my own projects from scratch. I'm in that lucky position. If I would have to deal with legacy code, it's obviously the best thing is to do integration tests first. Just call everything as like and do like black box tests. See what comes out. But whenever you create new features, get into the habit to using unit tests for these new features, at least for the new stuff, right? The old stuff can get tested with integration tests first, so you will get to a coverage of about like 50–60%. But and then you can use the coverage report to see, okay, where are my weak spots, and you can try to write unit tests for these things that the coverage report reveals. But I think the structure is still the same. I mean, you have is it Django projects? What are you talking about?
That's with actually not even related to Python, but
okay.
Java.
Yeah. Java, yeah. Not sure how you structured that there, but yeah, I would still have for every file there's a test file, and integration tests go into their own folder. Yeah.
Testing managers.
Testing managers.
Start doing like.
It's just an object instantiated and call the methods of the manager.
I mean, like you know, if you're extending something like a create user, where you're doing some logic and object creations and
yeah.
managers. So anything. I mean, my test cases I've been happy with for those at the moment, but.
I mean, you could even argue that you don't have to test that at all, because throughout your test suite you will probably create that object anyways. So the coverage will be there, but still, since I'm doing test-driven development, before I even write that manager, I will already have a unit test for that specific manager, right? So if I run the tests, usually when I develop a certain piece of code, I make sure that I only run tests for this small piece of code, so that is extremely fast, like less than a second. But after that, I mean, the manager will have 100% coverage, right? Because I have made sure that it has 100% coverage while developing it. It would probably even have 100% coverage if I didn't write any tests at all, because by running all the other tests, this object would have been created and this manager would have been used anyways. Because when you are implementing a manager, you are using it in your views, right? So by calling the integration test of that view, you would also already reach the cover. You would cover the manager already, but I will still write a unit test for every single method of that manager, obviously. Yeah. Okay, I guess we are done.